Okay, hello, 5.7. This one's titled the Pythagorean Theorem. Now, we've already done some of the Pythagorean theorems, but we're going to add to it and take it about 1 or 2 steps farther. This reads, the Pythagorean Theorem is probably the most famous mathematical relationship. As you learned in section 1.6, it states that in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. And here's the diagram. It's sometimes just read leg squared plus other leg squared equals hypotenuse. The thing to remember is this C has to be, or is always, the longest side. And as far as A and B go, you can actually switch them around if you want to. So A and B don't really matter as long as C is the longest side. And we know it's the longest side because opposite angle is the right angle. So A squared plus B squared is C squared. Well, this first example, next slide, slide 2, find the value of x. Well, I'm going to circle the longest side. It's that one. So A squared plus B squared equals C squared. The A and the B don't matter which one's which. I'm going to start 2 squared and then plus 6 squared, but my x has to be in place of the C. The x has to be the C. So now I can figure this out. 2 squared is 4. 6 squared is 36. That's x squared. Add those together to make 40 is x squared. Now, I know you can put the square root of 40 into the calculator and it would be 6 point something. But that's not what I want. I don't want the decimal. Look back at your answer. I'm sorry, look back at your directions. Give your answer in simplest radical form, which means leave it as a square root, a simplified square root. We know that x is the square root of 40, but remember your perfect squares. That can be written, instead of 40, it's the square root of 4 times the square root of 10, because 4 times 10 makes 40. Simplifying that, it's a regular 2, then the square root of 10. That is the answer you want. That is simplest radical form. I do not want the decimal. Let's try the next one, slide 3. Find the value of x, give your answer in simplest radical form. Again, I'm going to circle the longest side. That's my x again. So it's very similar to the previous problem. 4 squared plus 8 squared would be x squared. Simplify 16, that'd be 64. It's x squared. Add together to make 80. It's x squared. And so x really is the square root of 80. Now I know I could make that 8 point something on the calculator, but that's not what we want. This is going to be a 16 times 5. Because 16 times 5 makes 80, and that simplifies to 4 square root of 5. Again, 4 square root of 5 is simplest radical form. Okay, some new stuff. This reads, a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared is c squared, is called a Pythagorean triple. Pythagorean triples, there are no decimals. I'll circle the first one. 3, 4, 5. 3, 4, 5 is a Pythagorean triple. Let me draw something for you. If you have a right triangle where it's 3 there, 4 there, and 5 there, that's what the 3, the 4, and the 5 mean. Well, think of that as 3 squared plus 4 squared. Does that equal, oops, not 25, I'd be getting ahead of myself, equal 5 squared? Well, think 9 plus 16, does that make 25? And yes, it does. There are lots and lots of Pythagorean triples, but here's 4 of them. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. There's 4 examples of Pythagorean triples that would make a perfect right triangle. Now there's lots more than just 4. But the thing to remember is Pythagorean triples do not involve decimals. Look at the next slide. Find the missing side length. Tell if the side lengths form a Pythagorean triple. Well, I'm going to put an X right there. And of course, that's my hypotenuse. And I'm going to write 14 squared plus 48 squared equals X squared. 14 squared into the calculator. So make sure you have a calculator handy. 14 squared of my calculator says 196 plus 48 squared is 2,304. That makes X squared. Add those together. I get 2,500. Is that a perfect square? Yes. The square root of 2,500 equals 50. So this X up top is 50. I didn't get a decimal. 50 is a whole number. So yes, 14, 48, 50 does make a Pythagorean triple. Look at the next slide, number 6. Same thing here. Make the hypotenuse my X. So I'm going to write 8 squared plus 10 squared is X squared, or 64 plus 100 is X squared. 164 is X squared. So X is the square root of 164. And if I punch in my calculator the square root of 164, I get a decimal. So this is not a Pythagorean triple. Because the square root of 164 is a decimal. I think you need to simplify it into the square root of 4 times 41. So that would be a regular 2, then the square root of 41. So that would be my simplest radical form. Next slide, number 7. We can skip this one. I'm sorry. Skip this one. Put an X in that box if you would, please. It's the same thing as the previous 2. Last thing I want to talk about. You can also use, this is what it reads at the top, you can also use side lengths to classify a triangle as acute or obtuse. Here's the theorem. Pythagorean inequalities theorem. In triangle ABC, C is the length of the longest side. If C squared is greater than a squared plus b squared, then we have an obtuse triangle. But on the other side, if c squared is less than a squared plus b squared, we don't have obtuse, but we have a acute triangle. What's difficult sometimes to remember is the Pythagorean theorem is often stated a squared plus b squared is c squared. Notice where this c is. It's over on the right side of the equal sign. But when you do this theorem, the c has to be on the left side. The c comes first with this theorem. So that's kind of hard to remember, but just put that in your memory banks for now. Let's do an example. Well, here's the same thing. To understand why the Pythagorean inequalities are true, consider triangle ABC. See, if C equals a squared plus b squared, we have a right triangle. That's the Pythagorean theorem. If c squared is greater than a squared plus b squared, then it's a wide triangle, and this makes it obtuse. And again, over here, the c squared comes first. C squared, if it's less than a squared plus b squared, we have an acute triangle. With that said, let's do the last slide. This one reads, tell if the measures can be the sides of a triangle. I'm going to stop right there. Let's review. 5, 7, 10. If you remember from a previous video, I drew these little things. If I put the 10 there, the longest one there, will a 5 and 7 work? I would say yes, because 5 plus 7 is 12, and that would cover my 10. So yes, those would go together. Those two sides would bend together. If I bend one this way and bend one that way, they would touch at the top. So my answer to my first one is yes. Then it says, if so, classify the triangle as acute, obtuse, or right. So I have to do this one. C squared, leave a blank, a squared plus b squared. And I'm going to fill in that blank with either a less than symbol, a greater than symbol, or an equal sign. Let's do that now. C squared, C is always my longest. So C is this 10. So I'm going to put a 10 squared right there. Then my blank. Of course, I'll make that 100 in a moment. It does not matter which one's A and B. I'll just write 5 squared plus 7 squared. Again, it does not matter if it's 5 squared and 7 squared, or is it 7 squared then 5 squared. It doesn't matter. Let's go. 100 blank 25 plus 49. Add those together. 74. 25 plus 79 is 74. So what symbol goes in the middle? Is 100 be greater than, right? It'd be 100 is greater than 74. Well, if I get a greater than symbol, that means the triangle is obtuse. Less than would be acute, equal to would be right. But in this answer, 100 is greater than 74. That means that triangle would be obtuse. All right, that's all I have. Thanks for watching.